So this is the very first graph on your paper. We're going to take this graph and we're going to transform it. And we're going to start with translations. And so we're going to take this graph and we are going to start off with a vertical transformation. Which way is vertical? Up and down. We're going to move it up and down. So if you have these numbers added or subtracted on the end, that's what makes it move up and down. Now, this f of x stands for this graph right here in this problem. This is the f of x, and we're going to take that and we're going to move it up and down. So if we have a plus number on the end of this, it moves it up. If you have a minus number, it moves it down. Is that kind of reasonable? So, this f of x stands for this graph right here. So what is the plus 1 going to do to that graph right there? What's it going to move up? The whole thing, starting with the endpoints. It's going to move the endpoints up 1. And it will move all the rest of the points up 1 also because they have to go with it. So I don't see you writing this down on your paper. You see where this is on your paper? Example number 1. Now, if you take that graph and move it up, did that change the domain from the one we were looking at to start with if it just moved it up? It did stretch it out any? No. So it's going to have the same domain as the one we were just looking at. And so it is going to... But if you take this and move it up, is it going to change the range? This domain and range is going with this one that I have up here in red. So what is the domain and range of this one over here in red? So here would be the bottom of that graph now, and that would be at -2. Oops, And here is the top value of that graph now, and that would be at +5. Now, what's this table for? You can, I didn't use any tables to figure any of that out, but you can figure that out using tables. You can add this number to all the y values, add this 1 over here. So this would be 5, this would be -2, this would be +2. And so this red graph right here goes with this x values and this y values. And so you can make the transformation by counting on the graph. You can make the transformation by using a table. On one this easy, we usually don't use the table. We usually use the table more as it gets more complicated. This new graph is usually called g of x. The graph that is transformed is usually called g. Doesn't have to be, but that's kind of traditional. Okay. This one right here. What is that -2 down there on the end of this f of x? What's that going to do? How far? And so this point is going to go down to, this point is going to go down to, this point is going to go down to, and this is going to be my new graph. I can just count on the graph. I didn't draw it very straight there. I can just count on the graph, or I can actually go over here and subtract 2 from all the y values, and this would be these x's and these y values go with this graph right here, g of x. Is that hard? Not too hard? You got that? Going on to the next transformation we are going to do horizontal. Which way is horizontal? Left and right. That would be the x direction, right? The x direction goes left and right. And the way we're going to know that it's going to go in the x direction is this is in the parentheses with the x. You see that in your little box there? If this number is in the parentheses with the x, it's going to act on the x. It's either going to move it to the left or to the right. Now, we would think if it says plus 5, it would move it to the right. For some reason, it doesn't do that. If you have an x plus 5, it actually moves it left 5. This x is a liar. It looks like it should go positive, but it actually goes to the left. If I have x minus 5, you would think if it's in the parentheses with the x, it is going to act on the x. But you would think if it's a negative 5, it's going to go to the left. But it does not. It acts the opposite. It says negative, but it goes positive. It says positive, but it goes negative. The x lies to you. You just have to know that. It is a liar. It's going to lie to you. We're going to be doing these same kind of transformations all year long, and all year long, x is going to lie to you. So, just learn that right now. Now, what was I going to say? I lost my thought. So, let's look at this next example. This is x minus 2 in parentheses. If it's in parentheses with the x, it's going to act on the x. It's either going to move it left or right. So what's it going to do? Instead of moving it to the left like you would think, this is going to move to the right 2. So this is going to go to the right 2. This is going to go to the right 2. This is going to be my transformed graph. So, instead of taking the x values and subtracting 2, you take the x values and add 2. My new x values will be you do not have to count on the graph and fill in the table. I'm showing you how to do both because some people do better with just counting on the graph and some people do better figuring out with tables. You don't have to do it both ways, one or the other. Now, on this one that is in red, what is the domain? Eric? Mm-hmm. And what? Okay. And what is the range? Sergio? Somebody needs to help him out. Somebody have the answer for it? He doesn't know which one I'm talking about. What? Okay. Example number 4. Where are you, example 4? There you are. And so example number 4. What does the x plus 1 do to this graph? If it is in the parentheses with the x, what is it going to do? Left. If it's in the parentheses with x, it's going to go either left or right. And so instead of going right, it goes backwards. So I'm going to take this and go to the left. 1. That's going to be my new graph. And so then what is these domain and range? They're going with the new graph. What is the domain and the range for the new graph? Daphne, what do we have for domain? George, what do we have for range? So, this chart over here, if you want to use the chart, this is, instead of adding 1 to the x values, you are going to subtract 1 from each one of those x values. So that would be a -6 and a -2 and a 3. And then the new y values, they're not new. They're going to stay the same. So, do you think the translations are very difficult? Let's look at problem number 1 on your homework. Okay, this is problem 3 on your homework paper. What is the x plus 3 going to do? It's not plus 3. X plus 1. Instead of moving it in the positive direction, it's going to move it left. What's the -2 going to do? So you can move it left 1 and down 2. Left 1 and down 2. I haven't changed the shape. I've only moved it, and so it will still have the same shape. If you want to, you can use the table. Instead of x plus 1, it will be x minus 1 and y minus 2. So our new table will be -7, -5, -3, -1. I moved it over, so this is going to change my domain. Chris, what's my domain for my new one? That is correct. And Eric, I may have already called on you. Eric, what is the range? Mm-hmm. 1. Now, why do we have to skip over problem number 2 on our homework paper? That negative sign out in front, so we need to go back to our notes and look at what we do with that negative sign out in front. So back to your note paper, problem number 5 on your note paper. The negative sign out in front makes a vertical reflection. Vertical means up and down, so I'm going to take this and I'm going to flip it upside down. If you flip it upside down, it goes over the x-axis. If it goes over the x-axis, the y values multiply by -1. This is the original table, and to reflect it over the x-axis, you multiply the y values right here by -1. If you multiply by -1, it changes the signs. The x values stay the same. But that always seemed a little bit backwards to me, that if you're reflecting it over the x-axis, you change the y values until you put those points on the graph. These will be the points that go with my new graph, and so if I go to -5, -4, -1, +3, 4 and -1, do you see that that does indeed flip it upside down? That's what reflect over the x-axis means. It's flipped it upside down. It didn't move it left or right. It just flipped it upside down. And so it will have the same domain as the original one. The range is -4 to +3. How does that compare to the original range all the way back there at the top of your paper? How does this range compare to the range in example number 5? Did the number switch? Did the sign switch? Did you learn that in geometry to reflect something over the x-axis, it switches the points and switches the signs? Did your geometry teacher teach you reflections that way? They may have. And so, back over here in example number 5, it switched the order of the number and it switches the signs of the number to reflect. I'm talking about this range right here compared to the original. But what if the negative sign is in a different place? What do we do if the negative sign is right there beside the x? If it's right there beside the x, we are going to multiply the x values by -1. -1 times that number, -1 times this number, -1 times that number. The y values are going to stay the same. Then what's going to happen over here on our graph? We're going to go to 5 and +4, 1 and -3, -4 and 1. Do you see that that reflected it over the y-axis? If you reflect it over the y-axis, what's our domain now? Now, I'm not spending a lot of time explaining where the domain and range came from because of the quizzes I graded the other day, most of you were doing pretty well. So most of you understand that this is the bottom and this is the top. And when I'm writing range, I'm going from bottom to top. And so my bottom number is going to be at -3. My top number is at +4. So if you go to the second page of your notes, the reason you have 2 pages of notes is because all these graphs start taking up a lot of room. And when you get ready to put this in your ISN, you will unstaple it and you'll put it on your ISN on pages 12 and 13. You'll glue it down on 2 separate pages so you can see both of these pretty easily. And so right here at the top of page 2, you have all of your rules all written down together, so they're all together in one place for you. So these are the rules on the transformations. So next, instead of transforming that V shape like we've been doing, we're going to change to this shape right here. Is this written down for you in your notes? Is it already in there? Would you please, is the table already there? Okay, so would you please write the domain and range down for this first graph. And then what is going to happen in problem number 7? Problem number 7. Problem number 7 has more than one transformation. What is this going to do to your graph? How far? Right 1. There's a horizontal translation to the right. What is the plus 2? Is it going to flip it over any? Any flips in this one? Any reflections? No, that's all. And so we are going to move this right 1 and up 2. Right 1 and up 2. And you will have this semicircle and then this little line segment. This says x minus 1, but over here with my x, instead of minus 1, I add 1. Because x is a liar, you always do the opposite of what it tells you. This is plus 2, so you would add 2. So my new graph, the one in purple, would be here. Add these numbers to get add these numbers to get this column, add these numbers to get this column. This is my new graph up here that's in purple. What is my domain for this graph? Let's see. The domain is from here to here. This is my bottom point. This would be my top point. You ready for a challenge? Can you do this? What is the negative sign out in front going to do? What is the x plus 1 going to do? How'd you do on problem number 8? Did you get it filled in? Look at what you did. Look at what I did. See if you are correct.